Greetings, math fans. All right, so this is chapter 4, and this is our first day of the chapter. And what we're going to do is we're going to do systems of equations. Okay, that's actually the first part of the whole chapter. You guys have seen this before in Algebra 1, but we're just going to kind of review it. So, again, this is chapter 4. All right, so the first thing we're going to do is we're going to talk about graphing. And we just got done with a chapter with graphing, and basically what we're going to do is, just to give you kind of a quick synopsis here, you're going to graph two lines, and where those lines intersect, that's going to be a solution. Okay, so I mean, if you think about it, if I just kind of sketch something really quickly, and do you guys agree that, if I put a point here, that's a solution? Anything on that line is a solution. Well, if I draw another line that crosses it, okay, again, that's got a bunch of solutions as well. It's got here, it's got a whole bunch of solutions. But there's only one place where they both have the same solution. And that's what we're going to be looking at. Okay, so that's going to be our solution for both equations. Okay? So you got to be really careful. If you grab some of the graph paper that I have in the Google Drive, all right, that's actually kind of nicer because it helps you plot points and gets things a lot more accurate. One thing I can guarantee you, and if it doesn't work out, then you need to go back and check it, but I guarantee that that solution point that I'm going to give you guys will always be a whole number. Okay, so like this one could, if I just kind of roughly guess, this would be 1, 2. Okay, it'll never be a fraction, it'll never be any like decimal nasty number, it'll always be a whole number, because graphing is probably the least accurate of all of the, finding a solution to two equations. Okay, so anyway, let's start with the first problem here. If I give you guys y is equal to 2/3 x minus 2 and y is equal to negative x plus 3. So I give you two equations, and you're just going to graph them both. Okay, so I'm going to give you a little tip. So again, if you're having graph paper, that's kind of a good thing. If not, if you can just kind of follow along here, that's cool too. So remember, you guys should know how to graph these. Okay, you plot the y-intercept, which is our negative 2. You plot that point, and then the slope is 2/3. So you go up 2 and over 1, 2, 3. And you plot a point there. So I've got 2 points. Now here's the deal. Sometimes you need to plot more than just 2 points, okay? Because if I sketch this, it's going to be kind of a rough guess of where the line is. And if the line extends way out here or way down here, if you're not exact to where those both points are, you could be off by a little bit, okay? And if you're off by a little bit, that actually can prevent you from getting the correct answer. So what I'd like you guys to do is, we know how we went up 2 and over 3. So why don't you go up another 2 and over another 3. Okay, that's pretty much going to give you a nice graph. Kind of missed that point. Okay, but when you're, hopefully with your iPad, you may make something a little bit nicer. Okay, so I missed that point down there too. All right, so anyway, that's my first graph, and then what I'm going to do is I'm going to graph the other one. So if I go up 3, I plot a point, right, the slope is negative 1 over 1, right, negative 1, so you go down 1 and the left 1. See, notice I haven't hit any point yet, right, I'm not crossing yet. So just like what I did with the first line, I'm going to go down 1 over 1 a few times. So down 1 over 1, down 1 over 1. Now, by me going down 1 over 1 a few times, I notice, math fans, that's my solution right there, because it's the same point on both lines. All right, so I'm good to go. At least if I can sketch this now, right, this line is going to look like this. All right, and so what coordinate is that? You guys should all know the coordinate. That is 1, 2, 3, 0. So that's the answer, 3, 0. Okay, it's pretty easy, but you gotta plot these correctly and plot a bunch of points, not just 2 points. Okay. All right, let's try another one here. Y is equal to negative 1/2 x plus 5, and y equals 1/4 x plus 2. Okay, so go ahead and graph that. First one is up 5. Plot the point, and it's down 1 over 1, right? So, or down 1 over 2, sorry. Down 1 and over 2. Let's do that a few. So down 1 over 2. You may have to plot a few points, okay? But, you know, I did 3 points. I might have to plot more depending on where my other line is. But if I graph that one, the next line, well, here, let me just sketch this line now. The line is going to look roughly like that. As long as I have those points in there, I'm kind of good to go. Those points I plotted. Okay, the next one is going to be a Y-intercept of 2, and this one's up 1 over 4. So up 1, 1, 2, 3, 4. What? Okay, so again, that point is on both lines. So once I have that, let me sketch that line now too. There we go. So if you again count this over, you're going to get 1, 2, 3, 4. It's going to be 4, comma, up 1, 2, 3. 4, comma, 3 is your solution. Okay, that's not bad. Let's do one more. Y is equal to 2x plus 3, and y is equal to negative 3x minus 2. Okay, go ahead and graph that. So we're going to go up 3. Plot a point, and up 2 and over 1. 2 and over 1. Okay, and the other one, and I'm not going to plot that point quite yet because I kind of want to, I have a point to make here. No pun intended. The next one's going to be at negative 2. And the slope is negative 3 over 1. So I'm going to go down 3 and over 1. Now, if you notice, we're not going to, these two lines are not going to hit, right? I'm going to erase it in a second here, but I just want to show you, we have this line and we have this line. And I don't know really what that point is for sure. Okay, so I'm going to erase those two lines. And what I'm going to do is, you see this, the first graph we went 3 and we went up 2 and over 1. How about down 2 and to the left 1? Now let's do it again. Down 2 and to the left 1. Oh, down 2 and the left 1 right here. Okay, and then the other equation was down, it was the y-intercept was here. Let me do that in a different color. That intercept was here. So we plotted these 2 points, but again, it's not going to hit. So what I'm going to do is, instead of going down 3 and over 1, how about up 3 and over 1? Ah! There we go, math fans. That's the intersection point. So if I go ahead and graph these 2 lines, that one and that one. All right, and you can see we, like, by plotting those points, we got negative 1 comma 1. So that is my solution. Okay. So that's it. That's pretty easy, right? Okay, so that's the first part of the lesson. Let's take a look at the next part of the lesson. The question I'm going to ask you is this. Is the coordinate a solution? Okay, and I'm going to put here to both equations. Because remember what I told you, if I gave you a line like this, and that was a solution, there's all kinds of solutions, okay, but if I drew another line here, it may not, if that was the coordinate I gave you, it would be in a solution to the first line, but certainly not the next line, okay? It has to be on both. So let me erase this. What we're going to do is, I'm going to give you a coordinate. So the coordinate is 3, negative 2. This is the work I'm going to ask for. And that's the coordinate, and I'm going to say your 2 equations are 2x plus 4y is equal to negative 2, and 3x minus 2y is equal to 5. All right, and you're going to take that 3, negative 2. We've done this already. This is like last chapter. You're going to take that 3, negative 2, and you're going to plug it into the equation and see if the left side equals the right side. That's pretty easy. So I'm going to do 2 times, remember this is your x and this is your y. You guys should know that. So 2 times 3 plus 4 times negative 2 equals negative 2. Okay, so you get 6 minus 8 equals negative 2, and 6 minus 8 is negative 2. Hey, how you doing? Okay, so that's good. So that works. And then I'm going to plug that 3, negative 2. Just because it works in the first one doesn't mean it's going to work in the second one. If it does, then we're good to go. If it doesn't, then it's not a solution to both. Okay, so let's plug it in. 3 times 3 minus 2 times negative 2 equals 5. So we get 9 plus 4 equals 5. So 13 equals 5, which it doesn't. So this is no. So the answer to this whole thing, it says, and again, look at the question, is the coordinate a solution? And I even say, right, to both equations. And what's your answer going to be? It is going to be no, it's not, because it doesn't work on this one right here. That one happened to be okay, but that one did not work. So the answer again is no. It's not a solution. Okay, this is pretty mellow. Okay, so that is we did graphing. We asked if this chord is a solution, and the last step, or the last thing I want to talk about here, math fans, is substitution. This is a substitution method. Okay, I'll put your method here. Okay, so if I give you an equation of 2x minus 3y is equal to negative 1, and y is equal to 4x plus 7. Okay, substitution is really pretty easy. What you're going to do is one of the equations is going to be solved for you. So that's pretty much guaranteed when you use substitution method. So you see how the y is already solved here? What you're going to do is these two y's are the same. Okay, they're the same because you're trying to find a coordinate where the x and the y are the same. So those y's have to be the same. So what you're going to do is you're going to substitute this y into this y. Okay, so watch. This is what I'm going to do. I'm going to say 2x minus 3 times y equals negative 1. Okay? So again, that y is this. So I'm going to take where I see the y, which is the spot right here, I'm going to put in 4x plus 7. That's my y value. That's y. Okay, now I have everything just in terms of x. All right, and so I'm going to, here, let me erase this bottom here. And then what I'm going to do is I'm just going to solve for x. So solve for x. So you guys should know, distribute that negative 3. So you have 2x minus 12x minus 21 equals negative 1. Okay, got to know your algebra now. 2x minus 12x is negative 10x minus 21 equals negative 1. So you can add 21 to both sides. You guys should know your algebra. I get negative 10x equals 20. Divided by negative 10. So x equals negative 2. All right, cool. And how do I find the value of y? Well, you got to plug it in one of the two equations. And guys, this one's already solved for you. Why would you not plug it into this one right here? It's already solved. Okay, you could plug it into the top one, but you got to do a lot more work. So anyway, I get y equals 4x, and x is negative 2, plus 7. So y is equal to negative 8 plus 7, or y is equal to negative 1. All right, there we go, math fans. So y is negative 1, x is negative 2. So your answer is an xy coordinate, so it's going to be negative 2, comma, negative 1. That's your answer. Okay? That's what substitution is. That's why they call it substitution, because you're substituting the one y value into the other equation. All right? Let's try another one here. Negative 3x plus y is equal to negative 7. And y is equal to negative 2x plus 13. So I'm going to take that y and I'm going to stick it right in there. Okay, so I get negative 3x, this is the top equation, negative 3x plus y. So plus, and I'm going to put that in parentheses. So negative 2x plus 13 equals negative 7. So again, it's this equation, guys, except instead of putting y, I'm going to put in negative 2x plus 13. Okay? And I'm solving for x. So I get negative 3x. So let's just kind of, I know it's plus all that stuff, so let's just make it negative 3x minus 2x plus 13 equals negative 7. Okay, so negative 3x, combine like terms. Negative 3x minus 2x is negative 5x plus 13 equals negative 7. And subtract 13 from both sides. So you get negative 5x equals negative 20. So again, if you're not good with adding and subtracting positive and negative numbers, put in your calculator. I don't care. Just make sure you get it right. Okay, and then I'm going to divide everything by negative 5. So I'm going to write up here, x equals positive 4. Okay, and then what I do is I take that 4 and I plug it right into the other equation. Y equals negative 2x, which is 4, plus 13. So y is equal to negative 8 plus 13. So y is equal to 5. And so your solution to this one, math fans, is 4, 5. Okay? Cool. So one last one, and we'll be good to go. All right. Negative 2x minus 2y equals negative 6, and x equals negative 3y minus 1. All right, so the deal is, I've solved for x this time, but who cares? I'm putting that x into the other equations. One variable is always going to be solved. In this case here, it's x. Okay, so I'm going to write it as negative 2 times x. And what is x? It's negative 3y minus 1. And then I can continue on with this equation. Minus 2y is equal to negative 6. So we get negative 2 times negative 3 is positive 6y. So remember, I distribute that. Be careful, right? Plus 2 minus 2y equals negative 6. 6y minus 2y is 4y. So 4y plus 2 equals negative 6. I'm going to subtract 2, so I get 4y is equal to negative 8 divided by 4. So y equals negative 2. Okay, and then how do you find x? Plug it right into there. So x equals negative 3y, which is negative 3 times negative 2 minus 1. So x equals negative 3 times negative 2 is positive 6. So x equals 5. Cool. So your solution to this one is 5, negative 2. Okay, so if I graph these two equations, that would be where the two lines would intersect at 5, negative 2. Okay, remember, when they intersect, that means it's a solution to both of the equations or both of the lines. Okay? All right, math fans. Anyway, that's the first part of systems of equations. Hope all is good and have an outstanding day. Adios, math fans. Goodbye.